Since the Haber-Bosch process was introduced in the early 20th century, global crop productivity and our use of synthetic nitrogen fertilizers has skyrocketed. While nitrogen fertilizer is essential for maintaining this increased crop productivity, it's important to recognize that not all nitrogen we apply to soils goes where we want it to. A lot of it does end up being taken up by crops. Globally, we think it's about 35% in cereal grain systems. A lot of it remains in soil, which we like also because that means it might be potentially available to future crops. A lot of nitrogen, however, can leave the system entirely, either through gaseous emissions, such as nitrous oxide or ammonia, or it can leave through groundwater leaching or surface runoff. The amount of fertilizer that ends up in each of these pools can be affected by a wide number of environmental or managerial factors. One that we chose to explore in our study is the use of dairy manure. Dairy manure is typically applied in a liquid form, but the use of solid manures, generated through solid-liquid separation, has seen an increase in popularity in recent years. To explore the impact of each of these manure products on the fate of nitrogen, we established a field trial at the Arlington Agricultural Research Station in 2023 that lasted 1 year, with a lot of help from the good folks at the Dairy Soil Water Regeneration Project. We split our field into 16 plots. Each of these plots received one of 4 manure treatments shown on the left. We had a no manure, none treatment. We had a liquid treatment, which is our unprocessed liquid dairy manure, sort of our business as usual treatment. And then we have what I'm referring to as chemically separated solids and physically separated solids. They were referred to earlier as flocculated and evaporative solids. So for each of these plots, we also applied 180 kilograms of 15N isotopically labeled fertilizer, and that allowed us to trace where the fertilizer ended up at the end of 1 year. So our figure on the right shows for each of the manure treatments, where did 180 kilograms of synthetic fertilizer nitrogen end up? So for nitrous oxide, we saw that there wasn't a large difference between manure treatments. About 1 to 2 kilograms of our 180 kilograms applied ended up as nitrous oxide. We also didn't see big differences in the amount of fertilizer that was taken up by crops. It was between 45 and 50 kilograms, very consistent across manure treatments. Where we did see a big difference was in the amount of fertilizer nitrogen that was retained in soil. Both of the solid manure treatments, the chemically separated and the physically separated, led to a significant increase in fertilizer-derived soil nitrogen 1 year after application. What this translates to is fewer losses and more potentially available nitrogen for the next year's crops. Thank you.
Thank you, Josh.